Alright, this is example 2. It's very similar. I've given you a very similar example. It's not the one that you have on your handout, but I think this example will serve you to answer the other two questions on your handout. So let's look at this one. The question says, describe the transformations that must be applied to the graph of each power function f of x to obtain the transform function. Then write the corresponding equation. And then 2 says to state the domain and range, state the vertex, and the equation of the axis of symmetry for a function that is even. Only for a function that is even, because an odd function has a point of symmetry. So let's start by describing this. What type of transformation is happening to this? So first we know that there is a vertical stretch by a factor of 3. Factor of 3. There's also a horizontal stretch by a factor of 1 over k. In this case, 1 over 2 gives us 2. So a horizontal stretch by a factor of 2. Horizontal stretch by a factor of 1 over 2, which essentially gives us 2. Right? So horizontal stretch by a factor of 2. There's also a horizontal shift of 3 units to the right, and a vertical shift of 1 unit up. Okay, so we've described the transformations. Now they ask us to write the corresponding equation. So if this is the transformation shown in function notation, let's write it using the equation, the corresponding equation. So since we're dealing with an x to the power of 8 parent function, so the corresponding equation would be this. I'm going to put it in green. So the equation would be y equals 3 open square bracket 1 over 2 times x minus 3 close bracket close square bracket to the power of 8 plus 1. So this is the corresponding equation of that one. Now let's state the domain and range. Well, we know it's an even function. We know it's opening upwards. So we know that domain is going to be the set of all real, so x belongs to the set of all real numbers. And how about the range? Well, we know that for the range it has shifted up 1 unit, so the function doesn't exist below 1. Therefore y, the set of y values belongs to the range is y belongs to the set of all real numbers such that y is bigger than or equal to 1. Okay, the next question, it says to state the vertex of this function. Well, the vertex we can see right away. It's going to be 3, 1. So let's put here the vertex is 3. Vertex will be 3, 1. That means it's shifted 3 units to the right, 1 unit up. Okay, the next question says to the equation of the axis of symmetry. Okay, I'm going to try to put it right here. The equation of the axis of symmetry. Well, we look at the x values. So the equation of the axis of symmetry for this example, for this equation, is going to be x equals 3. That's the equation of the axis of symmetry for a function that is even, and that's how you would answer this question. So now you can go ahead and answer A and B of example 2.